Okay, let's look at how to solve the homework number 2, problem B, second order differential equation. So what we need to look at first is how to go through the characteristic polynomial process to arrive at our complementary solution over here. And so what you do is you set this differential equation. You pick a solution first where y equals e to the mx, so y prime equals me to the mx, and y double prime equals m squared e to the mx. And then you factor out an e to the mx, and you come to this polynomial right here. So you factor this polynomial out, and you come to m equals this root right over here, 1 plus or minus I. And so the way we learned in the lectures and in the notes is that when you have an I involved in your roots for the characteristic polynomial, then you plug in and you use cosine and sine of whatever coefficient is attached to your I. So right in this case we have a 1, and so we'll be using a 1 here for 1x, and in this case we have a 1 here. So we'll be using e to the 1x and e to the 1x in our general solution, or a complementary solution. So when you have your complementary solution, then you can move forward and look at your particular solution. So you pick your particular solution based on what is on the right-hand side of your equation here. So in this case, we have our e to the 2x times cosine x minus 3e to the 2x times sine x. So we have some coefficient times e to the 2x cosine x plus some other random coefficient times e to the 2x sine x as our general form for y sub p. So then what you do is you take your y sub p prime, y sub p double prime, and we need those two because we have y sub prime, and y. So you move through, and here I chose to group my my three equations here. My y sub p double prime, y sub p prime, and y sub p. And so what you can do is you can take those equations and you can kind of rewrite them, plug them all into your differential equation. So in this case we had y sub double prime, or y double prime, minus 2, and I'll highlight that here in yellow, minus 2 times y prime plus 2 times y sub p. And that's all equal to what is on the right-hand side of our equation up here in the original differential equation, right? So then what you can do is I choose to look at the system of equations, and I look at these two terms. Once I factor everything out, I look at everything that's attached to an e to the 2x times cosine x. So here we have our first e to the 2x times cosine x. We have 5a plus 4b. We have our next e to the 2x times cosine x. We have our negative 2 out front times 2a plus b. So we have 5a plus 4b from our first two terms. We have negative 4a and negative 2b from our next two terms. And we have positive 2a, from the last term there. And that's all equal to the coefficient on our e to the 2x cosine x, which in this case is just a 1. So you move through and you solve for your a value there. And then you want to set up your secondary equation because we have two unknowns. So we have for e to the 2x sine of x, we can come through e to the 2x sine of x. So you have negative 4a plus 3b. Here we have negative 4a plus 3b. we have our next e to the 2x sine of x. We have negative a plus 2b. And so I think I chose to do a little bit of additional simplification as I was running through here, because our next e to the 2x sine of x comes with a positive 2 and a positive b. And so I have a 2a and then these terms. And so I think when I originally did this problem, I chose to simplify things a little bit further. But in any way, you move through and you find, I'll switch colors here to red because we're getting towards the end. You have your you solve for A and you solve for B, and then you can plug those coefficients in here in your y sub p solution, right? And so that ends up being your y sub p. And we know from the notes and from different solutions that this form right here, y equals y sub p plus y sub c. And so I've gathered my two terms, which then come down, and you can add those together to come up with your complete solution for the second order differential equation. Homework 2, part B. So yeah, thanks.